This is Mr. Precella discussing trigonometry today with my trigonometry class. And if you're in my online class, this is probably the first time you've heard my voice. Today, to begin the course officially, we're going to define what's referred to as the 6 trigonometric functions. In order to do that, we're going to be discussing angles. And the way we're going to draw angles and measure them is if we have a XY axis, this is the x-axis, the y-axis. We're going to say that angles in standard position, if its initial side is the positive x-axis, and then to get the other side of the angle, we're going to move in a counterclockwise direction. So I've just drawn a red angle here. This is the initial side. That's the terminal side right here. We're measuring from the positive x-axis, and we're moving in a counterclockwise direction. This angle, we know the x-axis all the way to the y-axis, that would be 90 degrees. A straight line is 180 degrees, 270. A complete revolution would be 360 degrees. So this red angle looks like maybe it's 50 or 55 degrees. But the exact measure isn't important. But let's suppose we call that, now that's a symbol there is a Greek letter theta. We use the Greek letters a lot when working with this semester in trigonometry, because sort of paying homage to the ancient Greeks that did so much for today's modern trigonometry. In college algebra, you would have, or in any algebra class, you would have discussed a lot of different functions, linear functions, quadratic functions, those are the ones that have a parabola as the graph, square root functions, logarithmic, exponential functions, and so forth. What we're going to be doing is defining 6 trigonometric functions. And the way we'll do this is we'll say let theta be an angle in standard position, like my picture there. And let's let the ordered pair xy be a point on the terminal side of theta. So xy is just some point on the terminal, this red line here, xy. Now we're going to let r be the distance from xy to the origin. R is that distance. If you think of the distance formula, you get r is the square root of x squared plus y squared. Another way you might see that stated is you might see it written as x squared plus y squared equals what? If we square both sides, r squared. But r is a positive number. It's that distance from xy to r. So that's just setting up the definitions. Then, first trig function. Here's how we'll define what's called sine theta. This is S-I-N-E theta. And there's going to be 6 of these trig functions, and all 6 of them will have a 3-letter abbreviation. It's usually the first 3 letters. Sine theta, this is the only time I'll write it out like that with the E. The abbreviation that we'll see over and over is S-I-N. Don't say sin. It's Y over R. Sine theta is Y over R. Cosine theta, it's abbreviated first 3 letters, C-O-S, theta. is x over r. Tangent theta, abbreviated TAN, don't say tan, say tangent, y over x. Well, tangent measures y over x, that would be rise over run. So the tangent function is given the slope of that line, if you want to think of it like that. Those are the three primary trig functions. The next three are going to be what I refer to as reciprocal functions. Cosecant, C-O-S-E-C-A-N-T. We can't use the C-O-S because we've already used that for cosine. So we're going to use the first three consonants. C-S-C. That stands for cosecant. And that's the reciprocal of sine. That's why I put them both in purple. Cosecant is the reciprocal of sine. How would you take the reciprocal of the fraction y over r? Yeah, just flip it, r over y. So these next three functions are the reciprocal functions. Secant theta, abbreviated SC, is the reciprocal of cosine, so r over x, and cotangent theta, COT theta, is, by process of elimination, you can finally figure out if it's going to be the reciprocal of something. It's going to be the reciprocal of tangent. That's the only one we haven't done a reciprocal. So we have the three primary functions and their reciprocals. Now, while I'm doing all of this, I'll also be working some homework similar to the homework you find that you'll be having for the class. And what I did this morning was print out a copy of the homework, and let's see, let's read problem number 1. It says, sketch an angle theta in standard position such that theta has the least possible positive measure. Now, why would they mention the least possible positive measure? Let's discuss that. It's possible to have angles bigger than 360 degrees. If you have an angle bigger than 360 degrees, then you can just think of it as sort of a looping. Like an angle 400 degrees means loop one time. One complete revolution is 360, and then move an additional how much? If you've already moved 360 degrees, you need to move 40 degrees more. So 400 degrees would be loop around one time, then move 40 more degrees. 360 plus 40. What we say is that 400 degrees and 40 degrees are coterminal. They stop at the same side. Normally, when we have our angles in standard position, we're moving counterclockwise. If you move counterclockwise, that's going to be a positive angle. So if you take an angle and move counterclockwise, that angle's positive. And if you move clockwise, that's going to be a negative angle. So if you started at the positive x-axis and moved clockwise, then that would be a negative angle. So now looking at our first problem again. Get a little closer, read it better. Sketch an angle in standard position such that theta has the least possible positive measure and the point -512 is on the terminal side of theta. Well, this is just a multiple choice one, so you look and see which one of these, just plot the point -512. That would be left 5 up 12. Left 5 up 12 sure wouldn't be in quadrant 1. This first, the upper right hand corner is called quadrant 1, and then you go around quadrant 2, quadrant 3, quadrant 4. Somewhere in some algebra classes you would have labeled quadrants. -512 would not be in quadrant 1. I'm thinking the answer is going to be B. -512. It sure wouldn't be down here. This looks like they graphed +5, -12. So the answer here is B. And then after you draw the angle, notice you didn't loop around any, and also notice it moved in a positive direction. So that's why it says least possible positive measure. Now it says find the 6 trig functions. That's what we're about to do. Okay? Let's look at our definitions again. That's sine, cosine, tangent. Y over R, X over R, Y over X. In this course, there's going to be quite a bit of memorizing. This is different from algebra in the sense everything builds on itself. In algebra, we saw a lot of disjoint topics. We were working with logarithms. We weren't really also looking at piecewise functions and so forth, or graphing circles. Here, everything builds. We're going to spend the whole semester discussing just these 6 functions up here. So, I need to get a sheet. I'm going to flip over here. And this is problem number 1. We have the point -512. We had to graph it, that angle, something like that. It was answer B. Now we need to find sine, cosine, tangent. To do that, we need to know R. R is the square root of x squared plus y squared. So R, -5 times -5. This is the x, y. Oops. -5 times well, here, I'll write it like this one time. -5 squared plus 12 squared. That's going to be a 25 plus 144. So R is the square root of 169. So R is 13. So start writing them out. Sine theta, that's y over r. There's no way around knowing that. Okay? Just got to have that memorized. Oops. Y over r. Cosine theta is x over r. So that's x over r. Tangent theta is y over x. So we could have done that without even knowing r. -12, 12 over -5. Generally, you put that negative in front, like -12 over 5. Now the other three functions are the reciprocal functions. And it's going to be important that you remember which one's the reciprocals. Well, the three names of the reciprocals are cosecant, cotangent, and secant. Each pair, each function and its reciprocal has one co with it. For instance, most people don't have any trouble remembering that the reciprocal of tangent is which of these? Cotangent. Notice how each pair, there should be one co that goes with it. Cotangent is the reciprocal of tangent, so just flip negative 12 over 5 to get negative 5 over 12. Now, which one is the reciprocal of sine? Well, there must be a co with it. So it can't be secant because then there'd be no co with it. Each function and its reciprocal must have one co. Reciprocal of sine is cosecant. So just flip that, 13 over 12. The reciprocal of cosine, you see cosine already has the co, so it's going to be the secant. Negative 13 over 5. And so in your homework, my math, I'm just going to walk you through, and you got to punch in the numbers for sine, cosine, tangent, cosecant, secant, cotangent. Okay? This XYR stuff that we're doing here, we'll do all semester long. Let's see, number 2 is just like that one. I'm just sort of looking through these problems we're going to be doing. Let's do number 4. Number 4. Okay, sketch an angle theta in standard position. Okay, so you're going to sketch the angle, and the point that's on the terminal side is 0, negative 1. So here's what I'm doing. I'm asking myself, where is, pardon me once, where's that point over 0, down 1? Well, that would be right here, correct? So this angle, heck, we know the measure of this angle. Theta is 270 degrees. Which one is it here? It is B. So this is the point 0, negative 1. If you want to use the little formula r equals the square root of x squared plus y squared, that's fine to get your r. But if you remember, r is the distance between that point and the ordered pair 0, 0, the origin. If this is the point 0, negative 1, that distance here is 1. So r should be 1, but I'll go ahead and do it like this. R is the square root of x squared plus y squared. So 0 squared plus negative 1 squared. That's just going to be the square root of 1, which is 1. So that's going to make these a little easier. So this ordered pair, 0, negative 1. There's your x. There's your y. I'm going to make a note. R is 1. X is 0. Y is negative 1. Let's just start filling in. Sine theta. That's y over r. So negative 1 over 1, negative 1. Cosine theta is x over r. 0 over 1 is 0. So I'm going to plug a -1 in here, a 0 here. You might start noticing how it always gives you those options about undefined. Well, let's see. Tangent is y over x, -1 over 0. From algebra, you probably remember number over 0 is undefined, and that's right. -1 over 0 is undefined. All right, U and D, that's when you choose this. So undefined is when you're getting a number over 0. It spells no. Okay? Now cosecant, we're about to start these starting these reciprocal functions. Cosecant, have y'all got the hang of it? Which one is that the reciprocal of? It's certainly not the reciprocal of tangent. Remember, there can only be one co in each function and its reciprocal, in each reciprocal pair. Cosecant is the reciprocal of sine. So, flipping -1, the reciprocal of -1 is -1. Next, let's see, what is it asking for next? Secant. Secant theta, that's the reciprocal of cosine. So what I'm thinking is I need to flip cosine theta. And cosine theta, if you look back over here, cosine theta was 0. Well, what happens if I flip 0 over 1? I'd get 1 over 0, which is another undefined. So informally, what am I saying? The reciprocal of 0 is undefined. What about flipping undefined? The reciprocal of undefined, the reciprocal of 1 over 0 would be 0. And that's going to be used on the next statement. Cotangent is the reciprocal of tangent, the -1 over 0. So if I flip -1 over 0, flip tangent theta, which is undefined, so I would get 0 over -1, which is 0. So this answer right here, 0. So the reciprocal of 0 is undefined. The reciprocal of undefined is 0. And that's a very informal way of saying that. How are we doing on time? Let me find another one here. Let's do one that's a little messy. Problem number 8. Problem 8. There it is. It's the same type of problem. This XYR, we're going to have that going on all throughout the semester. We'll be using that. That's why there's so many of these here. Problems 1 through 8 are all the same type of problem. It's just changing the numbers. So the point is 2 comma square root of 3. The x value is positive, the y value is positive, so which one of these, A, B, C, or D, would be C? So 2 square root of 3 is on the terminal side. Now we're going to find the remaining trig functions. Because of the square root, we might wind up having to rationalize some denominators here. My math lab, it'll either, sometimes it lets you get by without rationalizing denominators, other times it says, you got to rationalize the denominator. Just sort of as practice and to review how to rationalize denominators, I'll be rationalizing them here. Okay? So we have the graph, okay? Right 2 up square root of 3. Let's find r. r is the square root of 2 squared plus the square root of 3 squared. Ooh, that looks terrible, doesn't it? So it's not that bad. 2 squared, we all know, 4. And y'all remember, how do you square a square root? A square root and a square, those are inverses of each other. They're going to cancel each other out. That square root of 3 squared would just be 3. So here my r is the square root of 7. So here's x, there's y, there's r. Sine theta, that's y over r. So square root of 3 over square root of 7. Multiply above and below by the square root of 7. That's rationalizing the denominator. So if there's a square root in the bottom, just multiply above and below by that. And we would get a square root of 21 all over. Square root of 7 times the square root of 7 is the square root of 49, which would just be 7. Multiplying a square root by itself is the same as squaring it, isn't it? So there's answer A. Now B, I think I'll do it in green. Cosine is x over r. So 2 over the square root of 7. Multiply above and below by square root of 7 to rationalize it. And we'll get 2 square root of 7 all over 7. Now tangent is y over x. Oh, that's not going to require any simplifying at all. Square root of 2 over, square root of 3 over 2. Y over x. Now we begin the reciprocals. Cosecant is the reciprocal of secant. Cosecant is the reciprocal of sine. So you can either flip this one, in which case you'll have to rationalize, or you could flip this. You'll still have to rationalize, but I think you'll get smaller numbers and less simplifying in the long run. I'm going to simplify the square root of, I'm going to flip the square root of 3 over the square root of 7. So I took the reciprocal of sine, and now I rationalize to get the square root of 21 all over 3. For secant, that's the reciprocal of cosine. Secant is the reciprocal of cosine. So I can either flip this, or I could flip what I originally had, the x over r. What would be the smart thing to flip so I don't have to do any more simplifying? Yes, this one right here. Did y'all hear that? Square root of 7 over 2. That's just the reciprocal of cosine, secant. And finally, cotangent is the reciprocal of tangent. So flipping 2 over the square root of 3. I'm going to have to rationalize it. There's a square root there in the bottom. So multiply above and below by square root of 3. Do any of y'all recall in algebra classes rationalizing cube roots? It's a little bit more involved than rationalizing square roots. Fortunately, I will be doing a square root. Okay? Then, so that's XYR. Problems 1, these first problems here. This is something we're going to do over and over this semester. This XYR, and then sine is y over r, cosine x over r, tangent y over x. There's 3 ways we're going to be defining the 6 trig functions. This is the first way. So it's going to be very important, very, very important that you memorize. Oh, this, that definition there. You need to also know r is the square root of x squared, or x squared plus y squared is r squared. Okay? Y over r, x over r, y over x. And then the reciprocal functions. Now, r is the distance from the origin to that point. So r is never negative. This symbol right here means positive square root, or at least non-negative. So keeping in mind that, and also how we labeled those quadrants. Remember? Right here. You label the quadrant 1, quadrant 2, quadrant 3, quadrant 4. In quadrant 1, x and y are both positive. In quadrant 2, x's are negative, y's are positive. So this is quadrant 2, negative comma plus. Quadrant 3, negative and negative. Quadrant 4, positive and negative. So quadrant 6 says, suppose your point is in problem 9. Suppose this point, x, y, is in quadrant 2. Decide whether this given ratio, y over x, is it positive or is it negative? If you're in quadrant 2, that would be right there. Quadrant 2. This ratio, I think I said y over x, it's x over y. X over y, would that be positive or negative? Well, negative. Negative divided by positive is, of course, negative. So, negative. Problem 10. Suppose you're in quadrant 3. If we were in quadrant 3, I'll do it right here. That would be down here. In quadrant 3, x is negative and y is negative. Well, what about x over r? X is negative. R is always positive. So negative divided by positive is negative. Then we sort of end these last few problems here, or at least the next 3, sort of light note problems. By that I mean, see, you can just sort of use the appropriate reciprocal identity to find the exact value for cosecant theta. We're going to use the rule identity the way you may have used the word rule, okay, in other math classes. An identity is just a statement that's always true. Sine and cosecant are reciprocals of each other. So if sine theta is negative 4 over 7, cosecant is negative 7 over 4. If tangent theta were 4, then its reciprocal would be 1 over 4. If secant is negative 8 over 5, what's the reciprocal of secant? Well, cosine. So what's cosine? Negative 5 over 8. Let's see, what else is here? Okay. Number 14. Ooh, maybe this is showing through too much. Let's see. How about something like that? Find the signs. This is the first time I've said it this semester. SIGN sign, not SIN sign. But, oh, what's happened? Lights have gone off. Maybe it's trying to say I need to get out of here. It says find the signs of the 6 trig functions of 115 degrees. Well, let's figure out which quadrant 115 degrees is. If we started here and started moving in a counterclockwise direction, there's 90, then move an additional 25 degrees. So here, This is in quadrant 2. In quadrant 2, x is negative, y is positive. So sine theta is y over r. Y is always positive. Excuse me, y is positive in quadrant 2. R is always positive. So sine theta is positive. Cosine theta, x over r. In quadrant 2, x is negative, r is always positive. So negative sine cosine. Tangent is y over x. Positive over negative is negative. Cosecant theta, that's the reciprocal of sine. The reciprocal of a positive number is positive. Secant theta is the reciprocal of cosine. The reciprocal of a negative is still a negative. And cotangent theta is the reciprocal of tangent. The reciprocal of a negative is negative. And you'll answer these questions on my math lab with a little pull-down menu. Okay? And then problem 15, the exact same thing. 336 degrees. Where would that be? Let's see, 90, 180, 270. It's down here in quadrant 4, which would have positive x's, negative y's. So sine theta, y over r, negative over positive, which is negative. Cosine theta. Get into the habit of always writing that angle. Don't just write cos. Or if you want to write 336 degrees instead of theta, I'm just putting theta because it's less writing. X over r, positive over positive, that's positive. Tangent theta, y over x, negative over positive is negative. And then, okay, so is cosecant theta is also negative. Secant theta is positive like cosine. Cotangent theta is negative like tangent. And that does it for this assignment, which is the first time we've actually defined the 6 trig functions. This is the beginning of the study of trigonometry, and I can't overemphasize these little definitions here. The XYR definition. I'm going to use this over and over and over. So we're out of time now. So work on this assignment, and I hope you're enjoying trigonometry. Thank you.